And welcome to the last presentation on Signify licensing. First of all, a very big thank you to all other groups for their amazing presentations on the diverse applications for Signify. This is, as I said, the final presentation by Group 1, consisting of Felipe, Peter, Nina, Timofey, and Maria. And we are going to talk about yet another application area, which is Interact City. Next slide, please. And next one again. So here it is. Interact City, a truly smart city. The main driving question here is, how do you make a city smarter and more livable? And the Signify way of replying to that means getting more value from what is already there, in order to make the whole much more than just the sum of its parts. Next slide, please. Interact City connected LED lighting system and management software provides a robust infrastructure to improve city services. It allows improving citizen safety, beautify public places, engage with citizens, and encourage civic pride. Interact City allows to reduce energy costs and increases efficiency so that these savings achieved, they can actually be further reinvested into new smart city projects. And Felipe will now elaborate further on the particular constituent elements for the Interact City.
Thank you, Maria, for the introduction. So just going a bit deeper into what are the main pillars of the smart cities. There's 4 key elements that we identify which bring all the benefits to this business model. So first of all, there's a lighting asset management. So by this, it is possible to commission new and existing lighting assets, detect faults, and monitor energy performance. It is possible to gain data-based insight on the city lighting and respond with real-time alerts. This is something that is not very much implemented in many conventional cities. There's one big element of energy optimization, optimizing street lighting performance and measure energy in real time. It is possible to lower the energy use and cost, and of course, reinvesting in other areas of infrastructure. Through the system, it is also possible to create a scene management that has the capacity to adapt the city lighting to time of no night when there's no light or the night during a season or rain event, for example. It is possible to increase the lighting in an area where there's a accident or crime, in areas where there's no lighting infrastructure. So this is something that can be implemented. It would be possible also to, for example, lower in 30% of the use of the light when nobody is around. So that's also a very efficient use of resources. Another pillar is the use of sensors that facilitate the detection of motion and presence, and also can adjust certain mechanism to direct the light in certain desired way. And the key element of this is that how all these elements interact with each other. So there will be a dashboard that can allow the lighting to communicate with other smart city elements, for example, smart parking, waste management, and traffic control. There's also many potential users that can be derived from this. We define the primary and secondary. So a primary use would be to create a livable city by making it safe and secure for the citizens through their innovative LED street and space lighting and creating atmosphere and scenery, which is what we mentioned before. As a secondary use, we can also think of creating active lighting for better city management. Sorry for the interruption. There can be also lighting on demand. There can be sensors at the street level, and also a better management of the energy usage, as we said before. Future users, we can also think of potential incident or accident detection. So through the use of using sensors on light poles, we can monitor and alert emergency services, for example, when unexpected traffic, sounds, or a crowd or sensor accident is detected. And we can also detect changes in the environment, which are useful for city planning. The sensors part of the platform can facilitate the capture of this data and facilitating the city to make quick decisions if necessary. I'm going to give the floor to Timofey, who is going to speak about the patent protection related to this concept. Thank you.
Thank you, Philip. So we identified two patents, which protect the exclusivity of this Signify solution, and also those patents gives value to this solution. Next slide, please. So the first patent is about method for information management and control of outdoor lighting networks. And the second one is about system which support autonomous vehicles via environment perception and sensor calibration and verification. So we will start with the first one. This one. Next slide, please. So as you see, the current practices of lighting infrastructure, renovation projects, as well as new constructions include several steps. On the figure, this is the upper part of the figure. It includes lighting design planning, project management, installation, operation management, and maintenance and upgrade. And typically each step is provided or executed by different entities or individuals, like vendors, contractors, lighting designer, facility manager, etc. And different supporting tools and platforms are used, which are usually not connected and not exchange information between each other in any way to optimize the process in general. And in many projects, lighting design and planning is neither linked or not take into account all the technology which are available on the market from multiple vendors. And the customization of products for the specific projects is not explored at all. And moreover, the operation management tools are completely independent from the designing tools at this beginning stage. And one of the problems that cities are facing increasingly budgetary pressures and need to be convinced of the true value and future potential of upgrading their lighting infrastructure. Increasing energy prices give motivation to upgrade the energy efficient LED lighting, but usually it's not enough in some cases just to justify the adoption of this cost and to implement the intelligent control systems. Currently, lighting innovations, project design planning doesn't take into account all options, as I said, and all the technologies available, and also existing tools and software do not consider any integrated solution already. But from the other side, range of technology and product options are quite big, and customers sometimes confused and cannot even see the value for implementing these intelligent solutions. So there is the reason why there is a need for tools that will integrate the value chain. And could you please jump back on the previous slide and help customers to identify the benefits and the reason why to upgrade the infrastructure and install intelligent control systems. And on the lower part of the figure, there is proposed lighting services platform, which integrates all the capabilities to enable streamlined approach to infrastructure innovation. So the platform will provide integrated in the better way to working with the customers, with the government entities, cities, towns, villages, from the early idea conception and planning stages to building the operating solution, which will clearly demonstrate the benefit to implement new intelligent technologies. And on the second slide, the solution is to deploy the central management system. This system will receive and process information from the light units, will determine objectives from the information which is received, will identify the units which are connected to the bunch of lighting systems, and also have an ability to determine and change the lighting requirements, model of illumination, how much it will cost for the lighting on the concrete part of the city, and also it will coordinate the operation of all the units across each other. And then the next slide, the benefits of this solution, that it will solve a problem between visibility and comfort in the city and on the street in particular. Also, the management system, this central management system, will allow better security, better coordination, and reduced management costs, because everything will be in one place. And the management of these lighting networks will provide benefit as energy saving and reduce lighting pollution and cost reduction. So this is what was about the streets and the cities. So the next patent is about cities and cars, particularly autonomous vehicles. One of the main services of the outdoor lighting, it's improvement light drivers' perception of the road conditions and also the surrounding area. And light serves as a middleman delivering signals from the environment. And these signals are captured by human eyes and further processed to the human brain to create visualization of the world around. But in mostly situations when car will drive autonomously, people simply will not care about the road, so they will not control the vehicle and will not be required to observe a road, and instead they will simply spend their time on the other activities. So the additional problem here, that autonomous vehicles will be vulnerable for the bugs or viruses or any malicious software or surroundings which will temper these sensors. Although they will have multiple sensors for cross-validating each other, will be still possible to manipulate that all sensors will fail, and therefore the roadside infrastructure should verify the vehicle's perception and help the vehicle to increase the driving security. In addition, sensor faults are the ones that occur when cars are in motion, and they simply cannot detect the faults in this stage, and the risk of incident is increased. And all the measurement errors accumulated over time during the movement, and also dust, rain, or any other interruptions because of the road conditions can simply prevent the sensors of the car from detecting any obstacles or any problems around, which also serious issue here. And the reason for this patent is to provide system which will detect the ground truth of the road conditions and monitor the road environment and store the measurement data. On the next slide, we will see how the system is utilized. So the system has the capabilities to enhance environmental perception of the road by receiving support information from surrounding lighting network infrastructure. So the car receives the information from the lighting outside. Also, there's a capability to quantify and calibrate the vehicle quality of perception of the surrounding environment. As an example, local area of near light unit which are staying on across the road. And it also improves the autonomous vehicle's performance by using this bunch of information which is collected from lighting network. And in combination with the vehicle sensor data, it supports the vehicle to avoid further failures, and thus the car has enhanced understanding of the road conditions. On the next slide, there is the benefits of the solution. Yeah, sooner or later, people will not be required to drive cars at all, and cars, we can even sit on the back seat, and car will be driven by itself. And in short and midterm, the roadway scenarios will likely include both mix of the cars, not only autonomous cars, but also cars which are driven by the driver. So in this case, this solution with using of the lighting system will support the autonomous vehicles in addition to the traditional illumination, and in the long term, when people will not need to observe the road at all, and there will be a new role for such lighting systems, which will not only guide the driver before the steering wheel, but also drive the car and the sensing systems.
So we're just going to look at improving and extending and looking at different use cases that might be applied to Interact City. I don't know if anybody here has been involved in any so-called smart city projects. I have been involved in a number, and sometimes it's hard to know whether the smart city project is for the city or is it for the people living in the city. And most of the time, it's initiated by city managers, and it's for the city managers. It's not necessarily for the people in the city. Interact City does and tries to address environmental concerns and the livability of the city, but let's focus on these a little bit more and whatever else. Groups 2 and 3 have already talked about the importance of light and the nature of the spectrum of light, and particularly they've talked about the blue end of the spectrum, and blue light really affects how people live, how the environment works. It affects how insects, it affects animals, it affects humans, and it affects their sleep. So if you have too much blue light on the spectrum, you won't sleep particularly well. It'll upset your circadian rhythm. It'll increase the amount of melatonin, or decrease the amount of melatonin that's produced by your body and whatever else. And so I think it's imperative from an environmental point of view that a more livable city requires light that adapts to the needs of the people in the city. And so in such case, we might have a lighting system that varies its spectrum according to the time of day or night, the time of year, because the time of year, different lighting and so on, and the location that the city is in on the earth and whatever else, different light. And so there might be attaching to that, there might be a patent, we call it control of lighting spectrum based on environmental factors. They could be sensed by the sensors that already exist in the lampposts from Interact City, and it might be called Interact Nature, because it's an extension, we'll say, of Interact City. And then the other one is the city sky is a very bright place. It's not dark. If you lived, when I grew up in country and long distance away from the nearest town, and nighttime skies were black. And now living in a city, nighttime skies are kind of pale, they're not black. And so a more livable city would be a city with a darker sky. And so, good for energy consumption if we use less light, good for PR and marketing and so on if we use less light, but also good for the environment around us and whatever else. And so we're talking about changing the lighting, adapting the lighting from the lamp to project onto the road, only onto the road, or only onto the thing we're trying to project onto. And maybe, as we've already discussed in some of the other parts of this presentation, the lighting is adapted to the scene that we're in. And so this would be also projecting light onto, for instance, if we're driving a car, you project light in front of the car and behind the car, but you don't project light anywhere else. And so again, this could be something that'd be patentable, active illumination in an area under a light. For instance, it could be an extension of the Interact City trademark, so it could be Interact Active Street, for instance, or something like that. Next slide, Philip. And then looking at a more livable city, how do we make a city more livable? And so some of the things that we could look at is how do we route ourselves around cities at nighttime, whatever else? How do we route, from a safety, just from a personal safety point of view, how do we route cyclists and pedestrians around a city where they feel safe? And feel safe for a lot of people is a well-lit, a well-illuminated street. or a well-lit, well-illuminated pathway or something like that. And so we might partner with people in Fitbit and Garmin and Strava and Apple who already have very detailed walking and cycling maps of cities. We might partner with them and bring our lighting awareness data to bear and combine the two of those and create a more usable routing an algorithm and so on that would present itself as a maybe a software API that map developers and map producers such as the likes of Google and whatever else could actually connect to. And again, that would be an extension to Interact City. The trademark can become Interact Travel, for instance. And I say patent there. I think, from a livable city point of view, this is probably made public domain, make it available publicly, and so that anybody can connect it and use to it, because it's good PR, good goodwill. And then lastly on this one is an extension of what Timothy was already talking in terms of making cars use the streets better. There is this going to be massive gray area between completely manual cars, as many cars are now, and cars of the future that will be completely automatic. And there will be this period of time where the automation paradox will exist, where people are driving neither automatic or manual cars. And so cars are smarter, but they're still driven by people. And so we have to make the streets safer. And one of the things that happens with the devices and the cues that driving assistant aids use, such as lines and stripes and markers on the road or whatever else, when it rains, they become very obscured and can become very obscured. So we might embed different types of lighting into our lampposts, such as IR, such as polarized lights, whatever else, that make the lines and the markings and so on the line easier to see for the driving systems in cars. And so we might have a patent associated with that, improved visibility using enhanced lighting, for instance. And again, that would be part of our Interact City suite of trademarks, this Interact Safe Active Street again, or Interact Road Safety and so on. And then lastly, in terms of our use cases, cities are constantly undergoing change. So buildings are constantly being built, buildings are constantly being renovated and so on. And sometimes these buildings can be very unsightly. And there is, there's plenty of ways of possibly covering that up. And maybe there would be large scaffoldings erected and whatever else. And sometimes you have hangings and posters hung from those. But you could also have a situation where we might hang a completely blank element, and then we may adapt our street lighting to project scenes or advertising or whatever onto these buildings. And so again, adapt the environment to be more livable, more friendly to the people living in the city. And again, that could be something that might be covered by patents, lightweight scaffolding structure, for instance, lighting structure, methods insisting to improve visibility of LED advertising and so on and so forth. Okay, that concludes group one. Thanks very much.